Okay, so I moved over in the park a little bit. I know the sun is behind me. I'm a little darkened, but hang with me. Right behind me over here is a hill. Okay, we live in a valley, so there's not a whole lot of hills accessible right here. And I imagine at your site, you might also feel like the same thing, that it's fairly flat and there's not a whole lot of rise in elevation or topography. Okay, so the first thing that I'd like you to think about with respect to elevation and topography is just something like the height of a tree or a building. Okay, I am 1.8 meters tall. And if I stand next to this tree, then I can use my height to measure exactly where 1.8 meters is at. So that's up there. If I go ahead and stand back and then look up, I can see that probably right up here might be the second mark. Yeah, probably right there might be the second mark of Sammy Heights. So first I had a mark down here at 1.8 meters. That would be one line of constant elevation. And then I have one more, and then the taller that the tree gets, there's probably another one, and then another one further up there. It's hard, of course, with our angled perspective to measure a tree like that, or measure a height like that. Sweet skateboarding, right? Okay, now if we go back to the hill and think about the same concept. So if I was to stand at the bottom of the hill, you could easily draw a straight level line from my eye straight into the hill, because eventually the hill, okay, so here's the level line, eventually the hill gets to the same level as my eye. Okay, wherever that's at, say maybe, you know, a little bit beyond the white pickup, that would be the point, just like on the tree, that it's risen up to 1.8 meters. And then clearly, if I was to stand at that point, I could also see an area that meets my eyes where the hill has come up to that same instant. And that would be another point of constant elevation at 1.8 meters. So all we're really demonstrating here is that drawing or taking a two-dimensional surface, kind of like your foil from the second exercise, is flat. And it's really hard to show how mountains and valleys and peaks and all of these things are in 3 dimensions in reality, but it's hard to show them in 2 dimensions. So the way that we do this in topographic maps is to draw lines of constant elevation. So if you take that point of constant elevation, and then if you were to walk laterally along the hill, so not uphill and not downhill, but to use something like a GPS or to use a level line to walk at a constant elevation, the path that you're walking would be the path of a topographic line. Okay, so what I'd like you to do, and this takes quite a lot of imagination, is either at the site that you are in, that you've determined, you can use Google Earth to look at your site and then see if you can trace lines of constant elevation on your map using Google Earth. Now, you know, I'm asking a lot of you, okay? There's a lot to topographic mapping. And other possibility that you could do is using the site maps that you'll find in the booklet, the Outdoor School booklet, is you could just imagine if the river is the lowest elevation, if you can see evidence for ridges and hills, then you can start drawing lines of constant elevation, okay? Now, let me give you a couple of rules, is that 2 lines of constant elevation can never cross, because where they cross, that would mean that's a place that's at 2 elevations at once, and that can't happen. So lines typically parallel one another as they move around. They never cross. That's kind of against the overall physical rules. And also, topographic lines never end. They don't just end in the middle of space. They either go out to the edge of the paper on one side or the other, which they'll connect to the next map, or perhaps if you have a hill, they might be conical. So just imagine that. If you're walking a conical hill, you could stay at a constant elevation and walk in a circle all the way around the hill. Okay, so that's just a little bit of exposure to topographic maps and the idea of lines of constant elevation. So enjoy. I hope that you enjoyed this day of outdoor school, whether this is outdoors at your site or maybe inside doing this a little bit more at the computer and paperwork. But I hope that you've had a wonderful Earth Day and you go outside and breathe the fresh air and feel the sun on your skin, feel the earth beneath your feet, feel the water that's in your body and bringing you alive as a Homo sapien or a human that lives here on planet Earth. Okay? Until next week, see you later.